Yeah, happy Monday.
How you doing, Joe?
Doing great. How was your weekend?
It was good. Yeah, some work, some catch up on a few things like cleaning, the usual stuff, and some socializing.
Nice,
Yeah.
nice.
How about yourself? I think you did some insane workout, didn't you?
Yeah, my legs are really tired. What was it? Hiked up West Granger, then came down and did a bunch of running intervals at the track. 'Cause I figured my legs would be so fried, which they are, that it's probably best just to get it all out of the way. So, gonna,
Yeah. Let's see if you can stand up tomorrow. We'll see.
yeah, the DOMS is a real thing. Delayed onset muscle soreness. So yeah, we'll find out how well that works. Um, cool. Well, this week we want to talk about something that we're asked a lot about and we consult a lot about, and we figured we should talk about it. And it's cloud data warehouse anti-patterns.
Yeah, we love to rant about this stuff too. Like, you really don't have to solicit our opinion to find out what we think. So we
Right.
figure we might as well throw it out there.
Yep.
So, yeah, and let's preface this by saying that I think our goal is to take the best things from traditional data warehouses and appropriately adapt them to a cloud environment. And by a cloud data warehouse, we're typically talking about a columnar database. So something like Snowflake, Redshift, BigQuery has really good performance in certain areas and kind of terrible performance in other areas. Now, I will point out that if you really need a traditional data warehouse with indexes and such, then even in the cloud, you're welcome to use Postgres. It's not as scalable as like a BigQuery or something, but it's going to play better if you need to do quick lookups, for example.
Hmm. Well, we see a lot of others like SQL Server. I think is
Yep.
still a good option as well. A lot of our clients are on SQL Server, and they have some optimizations. Things like column store
Yeah.
and temporal tables and stuff, which I think are pretty awesome. But in this for this conversation, we're talking about the cloud
Yeah.
native data warehouses, right? So as you point out, Redshift, Snowflake, BigQuery, Synapse. So I think we'll talk. We'll separate the discussion into three sections. So it's going to be like
Yeah.
general anti-patterns, anti-patterns around loading and storing data, and then anti-patterns on querying and processing data. So since we're talking about the first part, general anti-patterns, what are some things that we see a lot of?
Okay, so let's start with the first thing in our notes here, and that's just not understanding how your database works. And we see this a lot. So it's an example of what we sometimes call the curse of familiarity, and that is you get into your cloud data warehouse. It uses SQL semantics. It's fast. It behaves a lot like your MPP system that you're using on-prem, but actually under the hood, it's quite different. You're storing data in columns. You don't have indexes, and so a lot of things that are fast in a traditional MPP are really, really slow in a columnar system.
Right. Yeah, and I think also just this notion of separating compute from storage. Like this is
Yeah.
something where if you're dealing with an on-prem system, maybe a Teradata or Vertica or something, something that's a bit more old school, like the you're not going to be separating compute from storage typically, right? And so automatically, this is a fundamental thing to rethink. The cloud native data warehouses that have come up, I'm not, especially I'm thinking of Snowflake, right? Like they built a cloud native data warehouse from the ground up. They do a fantastic job. Uh, and it was in the notion from day one, it was separate compute from storage. This is something that you just don't get in an on-prem. And I think there's in understanding why this exists and how it works is very important for your success using a cloud data warehouse.
Yeah. And it really changes the cost structure. So if I buy like an Oracle MPP system, for example, I'm going to be paying typically like per node. So I'm going to pay for the storage I buy plus the compute. In the cloud, typically storage is really cheap and compute is the expensive part. And so, one pattern that you can adopt, for example, is pre-computation. You can have a lot more pre-computed tables for reports and such because storing them is super cheap and then they don't get recomputed every time. And so the compute costs go way down.
Right. Yeah, I think another general anti-pattern that we see is, treating your cloud data warehouse like you would, your on-prem, and especially your OLTP based data
Yeah.
warehouse. So if you come from a SQL Server, for example, or maybe your data warehouse is MySQL or Postgres or something, and you take those same exact patterns and apply those to your cloud data warehouse. And we'll get into some of these patterns in a bit, but
Yes.
you might have a very rough time and I think incidentally run up some unexpected costs, using your cloud data warehouse. And this brings us to another point. Understand the cost model of your cloud data warehouse.
Yes.
How are you going to optimize costs both from a loading data as well as querying and processing data? If you don't know how you're being charged, you should definitely find out.
Yeah. And this is a big change going to the cloud. Typically, you're now moving to an OpEx model away from a CapEx model. So, a traditional CapEx, you buy your MPP, it's maybe going to be a 3-year purchase, spend a few $1,000,000 on that, and you try to buy the right scale of data warehouse for what you need. In the cloud, you can continuously tune the knob on how much consumption you're going to have over time. But now your job is to like really optimize that consumption and not blow through a lot of money unnecessarily.
Yep. Yeah, exactly. That's why we definitely recommend reading through the documentation of the
Yes.
cloud data warehouse. It always comes back to the RTFM. Read the freaking manual. Like,
Yeah.
there's no shortcuts. And if you're going to take the time to invest migrating your data to a new cloud data warehouse, please understand how it works. It'll save you a lot of time and money and headache and everything else. So
Yeah. And in fact, I would give a couple of other pieces of advice. One is consider getting certified. So the Snowflake certifications are really great. The Google Professional Data Engineer certification is awesome. They spend a lot of time talking about update patterns and how to appropriately update BigQuery so that it's performant and not super, super expensive. And also find someone who already knows the tool, right? Because a data engineer who's been working in Snowflake for a while can give you advice that's hard to learn on your own.
yep, yeah, for sure. What are some other general anti-patterns that we see?
Okay, so Kimball, Kimball is something we talk about a lot. I think outright rejection of Kimball, facts, dimensions, traditional aspects of data warehousing is probably a mistake in most cases.
Hmm. Yeah, and I think to be fair, there's a lot of confusion.
Mm-hmm.
Um, you know, and I think part of the confusion is actually spread from the cloud vendors themselves, where on one hand they say, well, full normalization of your data isn't a good idea. I know for the longest time, the BigQuery documentations, it said basically like don't do a star schema. Star schemas won't be as performant as if you just denormalize your data. I think they made some under the hood improvements that have definitely changed that, and I think the consensus with BigQuery now is you can do a star schema. At the end of the day, right? Like you're going to if you've been using a star schema, I think you should just port it over. Actually, maybe with the caveat that there are maybe more modern data structures within these cloud data warehouses that you could take advantage of to increase performance. So I'm thinking of like nesting your data,
Yep.
using arrays and structs. Especially when you're talking about a fact table that may have a top line ID that may be the grain of your table. If you have a lot of repetition within that ID, you might want to consider just consolidating that into some sort of nested data because it'll help both your performance and your storage.
Yeah. And to be fair, I think analysts who've worked a lot on a traditional schema do struggle at first when you throw denormalization at them, when you have arrays and structs and other things. But once you wrap your head around these new data structures, they're a very nice way to think about the natural grain of the data.
Yep.
So like you said, maybe your first draft is just port everything over, and then you can do table versioning. You can have a second draft of a table where things are nested. You can maintain both for a while and then eventually say, okay, we are cutting over to this new version on this date. The old one is going to start being deprecated and then eventually shut down. So you need to start
Mm-hmm.
redirecting your queries toward the new nested table.
Yep. Makes sense.
Yeah.
Let's move on to loading and storing data. So what are some
Yes.
anti-patterns here?
Okay, so the number one anti-pattern we see, and we've seen it multiple times with many clients, is not handling updates correctly, typically in a change data capture setting. And so it turns out that if you try to do change data capture incorrectly in a cloud data warehouse, you're in for a bad time. So in particular, merges and updates are very, very expensive in cloud data warehouses, which means that if you try to do them continuously, it does not work well at all.
Yep. Yeah.
Yeah.
So I think our advice on this is understand how column storage works.
Right.
So especially if you're coming from an OLTP
Yeah.
based database, it's literally like orthogonal, right?
Yep.
So instead of thinking in terms of rows, you need to start thinking in terms of columns
Yeah.
and the effects of if you're doing updates for columns, merges, and also direct inserts. How does this work? How does the data need to be partitioned? How does the system take new data and either recluster it, sort it, and partition it internally? Like you need to understand these atomic things because unless you understand how it works, you're going to run into potentially some very expensive and possibly catastrophic issues. So
Yeah, exactly. I mean, one high level thing to understand. We'll get into a few technical details here, but not too many. When you do an update statement with a traditional row based data warehouse, the system looks up the row and says, "Okay, I'm going to modify this row," makes a change. In a column store data warehouse, the system has to scan the entire partition and then rewrite it with the changes, and that's an expensive operation. And so, what you want to move to instead is insert only, or at least your first stage is just insert only, insert the data, and then you can figure out what to do with the downstream from there.
yep, that does
Yeah,
help.
yeah,
And also understand, okay, so since I'm separating my compute from storage, I got a lot more leeway now, right? So I could potentially just partition my tables in such a way, like in BigQuery, you can do this, right? Where it's just
yeah,
you can do time partitioning. I think I can do integer partitioning, but basically, like I can split out my data sets, so I only need to load in, a small fraction of the data versus bulk loading everything in all at once. So it's sort of like incremental updates and inserts. On the other hand, how it's handled behind the scenes is fundamentally different than how it would be done in an OLTP system, for example. And I think this sort of falls in line too with in an on-prem world, you're going to obsess over your data size.
yeah.
So,
And yeah, in the cloud, it doesn't make sense to do that. Going back to that like pre-processing pattern you mentioned, you can maintain different versions of materialized data, and it's very cheap to do so. It can really save you a lot of money if you do things this way.
mhm. Yeah, exactly. And we'll talk about this with respect to querying in a bit too, but just
Yeah,
with your operations, when you're talking about merges and updates and stuff, try to avoid doing full table scans. Again, if you
yeah,
can isolate those to a particular range of partition data, within the data warehouse, that's going to make it a lot more cost effective, both from a performance standpoint as well as a spend standpoint. Because again, you're only isolating you know this data instead of everything. And the big anti-pattern we see is trying to do a full table scan when it may not be necessary.
exactly. Yeah.
Yeah. I think as far as querying and processing data, this is another I think aligned area because now that you've loaded your data in, you stored it. Now you got to query it. I mean, what are some anti-patterns that we see here?
Yeah. So again, it comes back to understanding the technology and applying the appropriate optimizations. I wouldn't say optimize everything up front. The nice thing is that it's fairly easy to re-optimize as you go along. At the same time, you need to understand high level how the system works so that you can optimize when you start hitting performance limits on things. And so, like
Hmm.
clustering and partitioning, like you were mentioning. And then, in addition, you need to start imposing some rules on your users too. So, for
Yep.
example, don't do select star. There's almost never a reason to do select
Yep.
star because select star scans every column in the table. And especially in a wide table, there are probably only a few columns that you actually care about. You also, in many databases, can impose a condition that says you must have a certain type of where clause. So, for example, you must limit date range, have a where clause for it, so you're not scanning all the date partitions.
Mm-hmm. Yeah. Yeah. The I think the select star is it's a big anti-pattern that we see with the column store
Yeah,
databases. So again, it comes back to understand how column store works,
yeah,
right? So um, like it's a good experiment to do in BigQuery. I think it's like very visible. So get a giant table. I think that the GitHub commits table, that's what a couple terabytes in size, and it's a public data
yes,
set. So get this public data set table, GitHub commits, um, preview the data. That doesn't cost you anything. But then, as an experiment, Do a select star query and don't run it. Just look at how much data that's going to process. And then because you've taken the time to understand how you're being charged, right? You're going to realize that it's probably a $10 query
Yeah,
because it's
exactly
two
right.
terabytes.
Yep.
But then
Yeah.
if you
And
start
so
selecting certain columns out of it,
gets
right? Then
way cheaper.
mhm.
Yep. Yeah. In fact, I think almost all the data in that table is inside the, what is it? They have actual commits in there. So they have
Mhm.
actual diffs in one of the columns. And if you don't select that column, then the table size gets way, way smaller.
Right.
Oh,
And again, this comes back to what we were talking about earlier with nesting. That's a nested table, I believe, as well,
yep.
right? So because you don't have, some columns may only be represented by, a very limited number of bytes versus, the children uh, of, certain columns in that table. Your query performance goes up, your cost goes down. That's awesome. But you got
Yeah.
to know how this works.
Yeah. And like you said, use the preview, right? So typically you run select star to preview the data. Well, in BigQuery, previewing is free. You just go to the preview panel. And in Snowflake, it's pretty cheap, right? You do have to have a warehouse running, but they do have a
Right.
preview option that just gives you kind of first rows of data, whatever that means. But it's not ordered, but it will give you a sample of data rows so you can kind of see what the data looks like.
Hmm.
Yeah.
Yeah, and I would say, especially in Snowflake, one thing we notice too, whether it's loading data or querying data, is using the same warehouse for everything.
Yeah.
So if you can help it, like, it's a Snowflake specific answer, but just, have a warehouse that's made for loading data, maybe another one for processing it, then another one for viewing it. There's no need to have, this monolithic, we need one, data warehouse to do everything. Um, just because you have options. But again, this also comes back to understand how the tool likes to be treated, right? So if you came to it from, you're an on-prem world and you try and do this with Snowflake, for example, I think you're just not going to have the best results possible. So,
Yeah. And another thing with Snowflake, well, both Snowflake and BigQuery, figure out where your bottlenecks are before you spend a bunch of money. I've been on teams that have spent, accidentally spent a few $1,000s in a day on Snowflake. And it's because the process was running slow. And so we cranked up the warehouse
mhm.
size and spent a bunch of money. And then it turned out that that made no difference in the performance. The bottleneck was not in Snowflake, it was somewhere else completely that was
Right.
causing the problem. So,
Yeah, and also you use the query planner. Understand what's going on
yeah.
under the hood, right? There might be a situation where you can optimize your query so it performs better.
Yeah.
There might be an issue where your data is, creating hotspots, which means that it's been loaded in such a way that like one node is, getting dinged really heavily, and so your query performance is going to go down. So just understanding all these concepts, I think, is going to give you a good boost. Maybe some other things to mention. Check out using views and materialized views. Especially in BigQuery, I think there's a really good case for understanding materialized views and how they work with streaming data. So,
Yes.
and actually back to the loading data too. We
Yeah.
talked about, since we're on no show streaming data, don't carpet bomb your cloud data warehouse with real time events coming in. Um, use mechanisms that these cloud data warehouses provide you for streaming data. So in BigQuery, you can do streaming inserts as opposed to just doing like direct inserts, which we don't advise. Use the streaming one if you have live data coming in. Let BigQuery handle it behind the scenes. In Snowflake, try and use Snowpipe. They have it
Yeah.
available. You should use it.
Exactly. And Snowpipe works really well. You're talking, latency of a few minutes, maybe like 3 minutes for data to arrive, which for most applications is actually very, very good, probably better than you need. So use that pattern. And again, yeah, use insert only. Don't be constantly updating target tables. Set an update cadence and figure out how much it's going to cost you based on what your needs are.
Yeah, but insert only, we're talking about change data capture that's doing
Yeah,
insert only, right? But you're capturing
exactly.
the create, update, delete events from the source system, but you're inserting those
Yeah,
only
yeah,
in. Yeah, yeah, exactly. Yeah, if you're doing stuff like that, then there's no need to go through and like update records because you already have the most recent records, right?
yeah,
So, yeah, I mean, we've seen cases where companies have tried to apply logic that they think makes sense, but I think is very against the grain of how the data warehouse wants to be treated, and especially when it comes to change data capture. Like doing just like I said, just doing direct loads. Every time there's a
Yeah.
change, inserting that into Snowflake, and Snowflake will eventually get the job done. It may not be in the time that you like or in the cost that you're willing to pay.
And sometimes it can take a very long time, right? It's very counterproductive. Like you can
Hmm.
end up hours behind if you handle things incorrectly.
Yeah, and I think our other advice with Snowflake especially is like you can get a lot of mileage out of an extra small or a small warehouse. If you
Yeah.
find yourself having to crank up to like a Excel or larger, like maybe take a look at what you're doing and try and figure out how you could get by with using a small. So I think
Yeah.
for a lot of customers that should be more than sufficient. So
Yeah. I mean, if you really have the data streams to justify that large warehouse and you can afford it, then great. But often it's just bad patterns that are driving your spend.
yeah,
Yeah.
exactly. So I think in summary, our suggestions are understand the tool, understand the cloud data warehouse you're going to be using, know the ins and outs of it, understand how column store works, understand best practices around loading data and querying data. Is there anything else?
I would just say understand modern data structures. So, in
Yeah.
addition to the fact that it's columnar, how to use structs, how to use repeated records, because at first they seem very annoying and inconvenient. But again, once you kind of grok what's going on, then you'll see, oh, naturally, this is an array. This is a struct.
Yeah.
Stuff that I used to just have in a flat table fits much better in these new structures.
Absolutely. Yep.
Yeah.
Cool. Well, I think that about covers it. So I think this is a good place to end it. But as always, fun chat, and we'll see you next Monday for the next Monday morning data chat. And also, I think this Friday, that would be, I think, May 7th, we're going to be doing a LinkedIn Live, YouTube Live data engineering show. And also, Monday morning data chat is now available on the major podcast platforms. So Apple Podcasts, Spotify, um, Google Play, and Overcast, and so forth. So go check it out. You can listen to us on audio if you don't want to watch the video. So cool. Well, thanks everybody. We'll talk to you soon. Bye.
Take care.